Okay, put this up a little bit. So I'm going to round this out. Tough talks to follow. I thought those were all really nice. And I know I'm standing between you and the poster session and, more importantly, coffee. So I will try to be relatively succinct. So what I'm going to tell you about is sort of a new framework, or at least a sketch of a new framework that I've been developing in my lab, looking at how we can investigate children's developing understanding of integrity in evaluating other people's epistemic practices. So I want to start with someone with a quote from Neil deGrasse Tyson, who's sort of become, at least in the US, kind of the patron saint of science in the public sphere, who says that science literacy is the artery through which the solutions of tomorrow's problems flow, right? So if we want to solve many of the problems that are facing us in the 21st century, we need to have a populace, not necessarily all of whom are scientists, but who all know how to answer a question or think about a question through an empirical lens, right? So we need a populace who have healthy empirical habits of mind, right? Unfortunately, it appears that science literacy is on the decline. So a number of research studies in a number of different countries suggest that people's sort of facility in terms of answering scientific questions or evaluating scientific sources, there have been different ways of doing this, seems to be on the decline. So that's troubling. So why is this? Well, maybe it's because of cultural beliefs about science. I don't know if you can read this. This says science has been canceled because your parents prefer to believe in magic. Or maybe it's our fault, right? Maybe scientists haven't done a good enough job communicating what it means to do science, right? But I'd argue that the explanation, or maybe at least the core of the explanation, might be quite a bit simpler, right? So thinking about this empirical sort of habit of mind, right? Part of the issue may be that we don't know what it means, or most people don't know what it means to answer or approach a problem scientifically. So this comes from a Pew Research Center study in the United States, suggesting basically about 1 in 5 people understand what it means to answer a problem scientifically, right? Okay, so what does that mean? Well, if we take a step back and think about what science really is, probably most people are thinking about science like this, right? So they're thinking about science as a lone person in a lab coat who's an expert, who's figuring out and discovering facts about the world, right? The end, and they write them down in a textbook and an article, and now there's truth out there, right? Whereas in reality, we all know that science is more like this, right? So we're all standing around talking about something, puzzling through the dark, trying to get towards something that looks like scientific understanding, and we all know that we haven't figured it out, right? And the point of this is that science is a fundamentally social endeavor, right? So we engage in scientific discourse, right? We make predictions, we gather data, we talk to other scientists, right? So I think if what we want to do is improve science literacy, well, as a developmental psychologist, and I, of course, and I bet many of you would agree, we need to start with the roots, right? So we have to think about how children reason about evidence in a social world, right? So to put this another way, to borrow a phrase from Laura Schultz, all the evidence that children encounter has what we might call a social history, right? So when children encounter evidence, they have peers, adults guiding them, demonstrating evidence, making claims about evidence, framing and shaping the way in which children are reasoning about certain problems, right? So we have to ask, how do children navigate that sort of social history? So in most of my work, I've really been focused on how children's social understanding, their social cognition, their sensitivity to intentions, including pedagogical intentions, shapes the way they make inductive inferences themselves. But in the last couple of years, in part inspired by this sort of new kind of crisis in fake news and epistemic vigilance, I've been looking at this from a slightly different angle, asking how children reason about other people's inductive inferences and other people's claims based on sufficient evidence or a lack of sufficient evidence, right? So I've been working to try to sort of sketch out a new framework for trying to look at this. And so I've come up with, and I would love feedback because these are probably the wrong principles, but there are 3 principles of epistemic practice that I think are really important. Now, you'll note that I've put scientific there in parentheses. That's because so far we haven't really gotten at science, and you'll see why I'm saying that, but that's where we're going. So I'm calling this epistemic at the moment. Right, so the first principle is don't see something, don't say something, right? And this is really the bedrock principle of thinking about the world in some kind of empirical way, right? If you don't have evidence for something, you ought not to make a claim. If you do have evidence, that's fine, you can say something about it, right? The second is be honest about what you expected to be true and when you're wrong. And the third is be honest about what you know and what you don't. Okay, now, I'm going to come back to 2 and 3 a little bit later in the talk, but most of my work so far in developing this kind of framework has been focused on this first, right? And this is really the bedrock principle of how you understand the world from a scientific or quasi-scientific perspective, right? So we've already heard a lot from some of the other speakers that is relevant to this, so I'm just going to present a couple of studies that we've done sort of following some of this work up, and then I'll come back to sort of how we might investigate the other principles. Okay. So in the first study, what we did is we recruited 4 to 7-year-olds. So we sort of wanted to have a broader age range to see what might be developing here. And we made it very simple for children, right? So Erica mentioned we're kind of hitting them over the head. Yeah, we did that too. So children saw a storybook presented on the computer, so it was a PowerPoint slide, about characters who were encountering sets of novel boxes. So there are 4 novel boxes. They expressed ignorance about these boxes, said they'd never seen them before. And they made claims about the contents of all of the boxes. And they did so on the basis of different levels of verification. So these were within subject conditions. They saw 2 trials of each type. On full verification trials, the puppet looked inside each of the 4 containers and then claimed, for example, there are marbles in all of these boxes. In the insufficient verification trials, the character looked inside one of the boxes and then said, I'm not going to look inside the other boxes. All of these have X inside. And in the no verification condition, they said, I'm not going to look inside any of these boxes. They all have Y inside, right? And the contents varied across the trials. And then what we asked them, similar to Emily's work, we asked them, was this okay or not okay for so-and-so to say, and the claim that they made, right? And then we gave them a 6-point Likert type scale to see how acceptable or not acceptable this claim is. Okay, so I know this graph may be a little small, maybe it's okay. So on the y-axis here is the 6-point Likert scale, so higher ratings mean more okay, more acceptable. The left-hand side of the graph is 4 and 5-year-olds, the right is 6 and 7-year-olds. Dark blue is a full verification, light blue is insufficient, and green is no verification. Okay. So what we see is that at both ages, children are rating the fully verified claims as more acceptable than either the no verification, the claims based on no verification, and importantly, and most importantly, on the insufficiently verified, right? So some knowledge is not enough knowledge to make a broad generalization about what's in all of these boxes, right? Furthermore, we asked them why. We had these justification questions and coded them in terms of whether they gave epistemic reasons, so either checking or knowing what's inside the box. We found clear developmental changes here, so the older kids give a lot more of those responses than the younger kids. But at both ages, the extent to which they give these kinds of good epistemic reasons is correlated with the extent to which they differentiate between the conditions. So this is promising, so pretty clear effects and some developmental trends. But this is kind of objective evaluation, right? We're asking them to judge how acceptable this is, right? And there's nothing really writing on it, right? So you'll note, right, even in the no verification, it's not so bad, right? They're not saying this is really bad, maybe because there's no harm, right? But they're kind of acceptable. They're not that terrible. So then we wanted to ask, so what if there's something writing on this? Right? Can children select who a third party should listen to, right? Most of the selective trust literature is about children's own learning, although Erica had a puppet there asking, right? So the question is, can children objectively say who a third party ought to listen to on the basis of who has the right kind of evidence. So in this study, we extended the age range down to 3-year-olds in order to see if maybe even younger children might be able to do this. And we simplified it. So now there's just one box, there's one container, and children are encountering that single novel box and making claims about it. One puppet looked inside the box. The other puppet looked at the box but did not look inside. So they did something epistemically relevant, but not the kind of action that gives them the right kind of knowledge, right? A third naive puppet who didn't watch them comes up and asks, they want to know what's in the box. Can you tell me what's in the box? The two puppets make competing claims about what's in the box, and then we simply ask children, who should he listen to and why, right? So now on the y-axis is the number of trials out of 4 on which they choose the verifying puppet, right? And what we see is that 3-year-olds are at chance here, so they're not successfully choosing on the basis of who looked inside the box. 4-year-olds and even more so 5-year-olds, 4 and 5-year-olds and even more so 6 and 7-year-olds are significantly above chance. And we ask them why. We see the same correlation between the extent to which they give good epistemic reasons and the number of trials on which they succeed. Okay, so can children select who a third party should listen to? Yes, at least by age 4 or 5, and when it's in this sort of simple context. But what about when they already have some knowledge of the informant, right? We're not giving them any information about reliability here. But what if they have some information about reliability? Does that interfere with their ability to do this, right? And this is kind of a key point. Right? Even if someone has a history of being reliable and accurate, we still need to evaluate the empirical process by which they make a novel claim, right? Consider your very trusted expert doctor, right, who finds a pill bottle lying on the street. You're not going to trust them about to know what's inside that pill bottle, even though they're the expert when it comes to medicine, right? Just to give one example. Okay. So to test this, now we just tested 4 to 7-year-olds since the 3-year-olds did not succeed in the last task. Children saw the same video as previously, but immediately preceding this, they saw the same puppets labeling familiar objects accurately and inaccurately, in the sort of classic trust sort of paradigm. And critically, on the verification trials, right, where they're looking inside a box or not, on half the trials, the puppet's verification was consistent or congruent with their previous accuracy, right? So the accurate puppet checked, the inaccurate puppet failed to check. And on half the trials, it was incongruent, right? So they have to override their knowledge about reliability in order to think about who has the right kind of knowledge, right? So they should trust the person who looked, even if it's the person who was previously inaccurate. Okay, so what do we see? Now we see something kind of interesting. So the 4 and 5-year-olds, again, are fine on the congruent trials. That's replicating the previous study. But they're a chance on the incongruent trials, right? So the past reliability seems to undermine their ability to evaluate empirical claims, right? Now, notice they're not overwhelmingly preferring the accurate informant, right? So they're sensitive to what kind of knowledge they have, but they're a little bit torn in terms of which way to go. Meanwhile, this seems to have no effect on the older children. They're above chance regardless of previous accuracy and whether it's congruent or incongruent. Okay, so I only have a couple minutes left. So in further work, what we're doing right now is we've been extending this. As I said, we haven't really gotten to science yet, right? So right now we're starting to look at warranted and unwarranted inferences. For example, evaluations of someone who has done sufficient causal exploration to make a causal inference versus someone who hasn't done the right kind of causal exploration to do that. We've also started to get back to some of our more behavioral and exploratory and spontaneous protest sort of measures. Both of these lines are looking quite promising, so stay tuned at future conferences, and we'll be able to really nail this down, I hope. Now, to turn back to the broader framework, right, the first principle is really about the fundamental idea that claims have to be based on evidence, and so far that looks pretty promising. But the second and third principles are in some ways simplifications of the very real problems of integrity and transparency that are facing psychological science today and being addressed by people like those at the Center for Open Science. right? So in our lab, what we're trying to do right now, what we're starting to pilot, we're developing kid-friendly scenarios that are kind of close analogs to the more or less honest practices in science, with the hopes of identifying what kinds of intuitive principles children have about how evidence gathering and claim making and inference making ought to be carried out. So just to give a couple of examples, right? So be honest about what you predicted and when you were wrong, right? The principle here is we ought to state our predictions, and when our predictions are wrong, we should not claim that what is true is what we expected all along, or that we're right despite evidence to the contrary, right? So some potential questions here that we could ask whether kids had these intuitive ideas. Do children understand that what's called harking is wrong, so hypothesizing after the results are known, right? So for example, do they understand that if you thought A and it turns out that B, you shouldn't just claim B, right? You should say, I thought A and it turns out B, let me do more work, right? Further, and I think this is a really interesting question, do children understand that when we do these kinds of practices, we do so in response to incentive structures, right? So the reason why people do this kind of hypothesizing after results are known, because it gets their papers published, right? You tell a better story, right? You're more likely to be published in a more prestigious journal. So putting this in sort of a kid-friendly scenario, right? If a child has a goal of looking smart or say winning some kind of prize from their teacher, right? Are they more likely to engage in these sort of questionable practices? Okay, and finally, be honest about what you know and what you don't. So here the idea is when evidence is inconclusive about a claim we want to make, we ought to be transparent and present all the evidence, even that which conflicts with our claim. Right, so here we could ask, do children understand that you need to report all your data, all your evidence, not just the evidence consistent with your hypothesis, right? So if you hypothesize A and the data suggests something more like A or B or A and B, do they understand that you shouldn't just say A, right? In addition, do children understand that you ought to report all your results, including null results, right? And not just the interesting findings, right? So if you're trying something out and you try A, and nothing works, and then you try B and it works, you don't just say B, right? You say that you've tried all these things and they didn't work, B sort of works, and now you're going to test more, right? So the idea here is to take some of these principles that are kind of resurgent in psychological science and people are paying a lot of attention to, right? And to which the public kind of says, isn't this what you're doing all along, right? Do children have those same kinds of intuitions? Okay, and just to end with Neil deGrasse Tyson, right? Ultimately, my hope, this is just the beginning of this research, but is to develop a coherent picture of how children engage and evaluate the empirical process, and ultimately to develop tools for fostering these kinds of empirical habits of mind in young children. So, thanks. And so we've got time for 2 or 3 questions, or you can go get coffee.
Thank you for the talk. I was wondering about a first data set you presented, where it seemed that in the no verification and the partial verification conditions, as if children got more accepting. So I don't know if that's significant, but
you mean developmentally?
Yeah.
Yeah, it's not significant, but it does sort of look like that, and I'm not quite sure what to say about that. You know, it could be that, you know, if you think about, there's all sorts of reasons why you make a claim here, right? And maybe older children are better at generating, you know, benefit of the doubt explanations of maybe he knows, maybe he's just really good at figuring things out by looking at boxes, right? You can come up with, and the younger children just more cut and dry. I don't know.
That would stand for adults as well. So if this is a trend of being more, and we're just getting less and less accurate.
It could be, yeah. I mean, I don't know if that's what's going on in adults, but it's true that, and especially when we have reason why we want to give someone the benefit of the doubt, say they're a member of our social in-group or we have some kind of affiliation with them, right? Yeah, we are better, we're better than maybe the little kids at coming up with reasons why maybe that person knows what they're talking about, even though really it's clear that they don't. So yeah, I mean, I think it's really important to trace, you know, what happens once kids are entering the school system, right, and and entering a formal science education. Does this fall apart, right? Do they lose this ability in some way? Sort of what is the developmental trajectory? I'd really like to look at that.
Thank you.
Thanks.
Hi, thanks. This is really cool stuff. So my question, I'm over here.
Thank you.
My question is related to the one that was just asked. So I was sort of surprised to see how poorly 6- and 7-year-olds especially are doing on some of these measures, that they're not anywhere near ceiling, or here they're not rejecting nearly as much as you would expect. And sort of relatedly to the previous question, I was wondering whether you gave them any information about whether or not these puppets, these characters, knew anything about the box when they came in, or were they just introduced, like, because the kids could assume that, like, I don't know, maybe these guys know something about this box to begin with, otherwise they wouldn't be saying this.
Yeah, I mean, so because of time, I didn't show you the videos, but yeah, so we do have the characters explicitly express ignorance about the boxes. So they say, I've never seen these before, I don't know anything about them. So they don't say anything about what's inside, but they do express ignorance. But in terms of why kids are not, right, even the older children are not at ceiling, you have to remember that this is pretty hard. These claims could be true, right? They never see what's inside the boxes, right? They never know what the reality is. And that's sort of what makes this a challenging issue. Is it's not like these aren't inaccuracies, these aren't clear factual errors, right? They're things that are plausible, right? And I didn't go into all the properties of the various objects that were said to be in the boxes, but they were all totally plausible, right? So there's no a priori reason to think that they're wrong, to think that they couldn't be true. So children have to inhibit their own lack of knowledge, right? Of like, I don't know what's in the box, but I believe that he knows and I don't think he knows. And I think that is more challenging than something like reliability or accuracy where you have a clear right and wrong. So my guess is that that's why they're not at ceiling, but that's an open question.
Thank you.
Okay, so I think we're out of time. Thank you very much for coming, and I hope you learned something.